The ancient Egyptian calendar was a solar calendar having a fixed 365 days per year. Now the Earth revolves around the Sun at almost exactly 365.256,363,004 days, and unlike other calendars that have leap years, wherein the discrepancy is corrected every certain period of time, the Egyptian calendar does not compensate for the 0.256,363,004 of a day difference every year. This means the Egyptian New Year is observed one day earlier or slides back one day every approximately 4 years. The Sothic cycle is a period of about 1,461 Egyptian calendar years of exactly 365 days each, which is equivalent to about 1,460 solar years, averaging 365.25 days each. At the end of one complete Sothic cycle, the calendar having 365 days a year loses enough time that the start of its year or its new year once again coincides with the heliacal rising of Sopdet, Egyptian name, or Sothis, Greek and Latin name, which Egyptologists associate with the star Sirius. I said the Sothic cycle is about 1,460 solar years because the start of a new Sothic cycle depends on actual observation of the star rise of Sopdet falling on the day before the Egyptian New Year's Day, and the precession of Earth's equinoxes causes the date of the heliacal rise of stars to move forward slowly in time. For example, the star rise of Sirius was June 18 Gregorian calendar in 3500 BC, but was June 30 Gregorian calendar in 2000 BC, or an advance of 12 days in a period of only 1,500 years, which, by the way, is just 40 years more than the supposed 1,460 years Sothic cycle. Because of this, the actual observed period of the Sothic cycle should be less than the calculated and presumed 1,460 solar years. The Egyptians call the start of a new Sothic cycle a great or divine year, and it corresponds to the life cycle of the sacred phoenix or the Bennu of Heliopolis, which is a symbol of rebirth. Now the first month of the Egyptian calendar is Thoth, which is by name only the first month of the flooding season, which the Egyptians call Akhet. I said by name only because this becomes true solely at the start of the Sothic cycle, when the first day of the first month of Thoth starts on the heliacal rise of Sopdet. Most scholars agree that the Egyptian day began at dawn before the rising of the sun rather than sunrise, and the heliacal rise of Sopdet is cited during this time. Thus, the Sothic rise falling on the first day of Thoth marks both the end of the previous Sothic cycle and the start of a new one. The concept of a Sothic year comes to us via a Roman author named Censorinus. In 238 AD, he wrote that 99 years before, or in 139 AD, a great year began on the Egyptian calendar, which is based on the motions of Sirius, the dog star, and that it is 1,460 years long. Astronomical calculation definitely dates this heliacal rising to July 20, 139 AD Julian calendar. Theon of Alexandria, who lived a century after Censorinus, agreed with him and declared that the previous Sothic cycle began with the era of Menophres in 1322 to 1321 BC, or exactly 1,460 years before July 20, 139 AD. Armed with that information, the Egyptologists looked for a pharaoh named Menophres. They settled on Ramesses I because one of his other names was Menpetire. Since Ramses is credited with only a one-year reign, both he and the beginning of the 19th dynasty were initially pegged at 1321 BC, although it has now been revised to 1292 BC. The earliest record of the start of the Sothic cycle can be found in the ivory tablet of Djer, the third pharaoh of the first dynasty of ancient Egypt, whose capital was in Thinis. This heliacal rise was dated by Egyptologists on July 17, 2773 BC Julian calendar. However, this date is too late for Djer's reign, which is dated circa 3000 BC. And this is a big problem because the Sothic cycle was used for absolute dating of the Egyptian chronology, not just for the 19th dynasty under Ramses I, which I discussed earlier, but also for the 18th dynasty and the 12th dynasty. And if the Sothic rise calculation for Djer's reign is too late, then this means the Sothic rise calculation used for dating the other dynasties may be faulty as well. In my previous video titled Sothis is Aldebaran, the eye of Ra, and the red Sirius is Ayin, the eye of Horus, the two eyes of Taurus, I discussed in detail the imagery found in the ivory tablet of Djer as follows. Thus, in summary, the ivory tablet of Djer is telling us that the heliacal rise of Sopdet Isis, or Aldebaran, the sun disk of Ra between two horns, whose star rise signals the start of the flooding season, happened in the constellation Taurus, the stooping bull representing Apis, the son of Hathor, while Venus, the feather of Ma'at Isis, representing Horus, was between the two horns of Taurus on the day a new Sothic cycle started. The actual location of Thinis, the capital of the first dynasty pharaoh Djer, remains undiscovered, so I will be using the coordinates of the center of a total solar eclipse located in Egypt instead. This eclipse, I believe, occurred sometime during Djer's reign. Using stellarium and setting the algorithm of delta T to Chaperon tools and Chaperon 1991, the location at coordinates 27 degrees, 31 minutes, 57 seconds north, 33 degrees, 10 minutes, 59 seconds east, the date to May 15, 2817 BC, or negative 2816 in astronomical year numbering, and at 2:16 UTC, one can see the heliacal rise of Aldebaran. Setting the time at 2:34 UTC, one can see Venus rising from the horizon. According to Stellarium, its heliacal rise should have happened on May 21 still, or 6 days later. However, looking at Venus' visual magnitude at that time, it was already at 0.73 or below magnitude 1, which is the limit for naked eye visibility during a total solar eclipse and is similar to the day sky during early dawn. So it may be possible that May 15 was also the heliacal rise of Venus coinciding with Aldebaran, a not so common coincidence. Note also that the ivory tablet of Djer placed the Ma'at feather representing Venus below that of the son of Ra, representing Sopdet or Aldebaran. This implies that the visible rising of Venus above the horizon followed that of Aldebaran, which was actually the case on May 15, 2817 BC. Setting the time at 15:33 UTC, one can see a total solar eclipse just 30 minutes before sunset, allowing Mercury to be visible during daytime. The center of the eclipse was and still is part of Egypt, and I believe this is the true location of Themis. Note also that this eclipse was positioned at the left side of the club of Orion, while Orion and his club was positioned at the left side of Taurus. Now look again at the ivory tablet of Djer. There, one will see a club at the left side of Taurus, or the stooping cow. Furthermore, at the bottom left side of the club, one will see a circle with an inclined cross inside. The club at the left side of the stooping cow in the ivory tablet is, of course, the club of Orion, while the circled cross symbol at the bottom left side of the club represents the solar eclipse which happened at the left side of Orion's club. This circled cross is below the Sun of Ra and the Ma'at feather, implying that the eclipse happened after the heliacal rise of both Aldebaran and Venus on that same day, and which actually was the case. Now note the arm and hand pointing at the club in the ivory tablet. This arm is the right arm of Auriga, which is also pointing at Orion's club in the sky. Auriga is often portrayed as a charioteer, and the square with 9 smaller squares inside represents his chariot on top of the circled cross, the eclipsed sun serving as its wheel. The chariot on top of a circled cross wheel is a very ancient symbolism. The 9 smaller squares inside the square chariot represents the 9 deities of the Ennead, namely Shu, Tefnut, Geb, Nut, Osiris, Isis, Set, Nephthys, and Horus the Elder, while the sun god Atum is represented by the circled cross. Now notice the falcon sitting on top of the 2 boxes joined or stacked together. The 2 conjoined boxes represent the conjoined twins Castor and Pollux of Gemini, and the falcon sitting on top of the boxes, or the foreground of Gemini, represents the falcon god Horus, who was represented by Mercury that day, and which momentarily appeared in Gemini during the time of the eclipse. Apparently, Horus is represented not just by Venus, but also by Mercury as well, which are the 2 planets closer to the Sun than Earth. I believe May 15, 2817 BC is the correct date of the earliest recorded heliacal rise of Sopdet, and was the Egyptian calendar's first ever New Year's Day. Note, however, that May 15, 2817 BC is about 44 years earlier than the July 17, 2773 BC date calculated for the star rise of Sopdet during Djer's reign based on Censorinus' account. And this is understandable. After all, almost 3,000 years have passed between the first recorded Sothic cycle and the time of Censorinus. Because the precession of the equinoxes advances the date of the heliacal rise of stars slowly over a period of time, the Egyptians cannot use a fixed period of 1,460 solar years to mark the end of a Sothic cycle. So the Egyptians must use another celestial sign to mark its end, and this marker should coincide with the star rise of Sopdet for the effect of the precession on both the celestial marker and the star rise of Sopdet to match. The celestial sign that coincided with the star rise of Sopdet in May 15, 2817 BC was the solar eclipse. And a solar eclipse coinciding with the heliacal rise of Sopdet can be calculated or predicted because it occurs regularly over a fixed period of time. The orbit of the moon is inclined with respect to the orbit of the sun, and a lunar node is either of the 2 orbital nodes of the moon, that is, the 2 opposite points at which the orbit of the moon intersects the orbit of the sun. A lunar eclipse can occur only when the full moon is near either lunar node within 11 degrees 38 minutes ecliptic longitude, while a solar eclipse can occur only when the new moon is near either lunar node within 17 degrees 25 minutes. Now notice the eye of Ra, a symbol of Sopdet, represented by the red solar disk. Below it, one can see a two-headed cobra named Djer looking at opposite sides of each other. I believe this two-headed cobra represents the two opposite orbital nodes of the moon, responsible for solar and lunar eclipses. In Hindu astrology, the two opposite lunar nodes are named Rahu and Ketu, and they are both represented as a snake. Because the moon has two lunar nodes located opposite each other, and because the synodic orbital period of the moon is about 29.530589 days, two successive eclipses, one lunar and one solar, happens consecutively and separated by about 14.7652945 days from each other, or half the synodic orbital period of the moon. So for the ancient Egyptian astronomers, a solar eclipse visible in Egypt on the same day as the star rise of Sopdet, or a lunar eclipse visible in Egypt about 15 days earlier, should be the celestial marker they are looking for to declare the end of the current Sothic cycle and declare the beginning of a new one. Now, because the orbital plane of the moon recesses in space, the lunar nodes also recess around the ecliptic. This cycle, measured against an inertial frame of reference, is 18.599525 years, or about 6,793.5948551 days. Earth's orbit around the Sun is about 365.256363 days, while the sidereal orbital period of the moon around the Earth is about 27.321661 days. 523,046 days is a period of time when the orbital periods of the lunar nodes, the Earth, and the Moon make nearly whole cycles each. During this period, Earth makes about 1,431.996956 cycles, or about 1,432 complete solar years, which is just 28 years short of the 1,460 years associated with the period of the Sothic cycle by Egyptologists. Also, in 523,046 days, the moon makes about 19,144.00458587 cycles, or about 19,144 complete cycles, while the lunar nodes make about 76.9910498 cycles, or about 77 complete cycles. Thus, it is expected that a solar eclipse will happen on the same day as the heliacal rise of Sopdet, or Aldebaran, 523,046 days after May 15, 2817 BC, or on May 23, 1385 BC. I believe this is the start of a new Sothic cycle which Theon of Alexandria declared began with the era of Menophres, and which followed the Sothic cycle which started during Djer's reign. It is about 63 to 64 years earlier than the 1322 to 1321 BC date that Theon calculated for this era. And indeed, a solar eclipse happened on May 23, 1385 BC at 5:13:24 UTC as calculated and expected. Also, the heliacal rise of Sopdet, or Aldebaran, occurred on that same day at 2 UTC using the same coordinates that I used for its star rise during Djer's reign. You can verify this using Stellarium and by setting the algorithm of delta T to JPL horizons. This shows that both the star rise of Sopdet and the solar eclipse happened on the same day. However, because of precession of the equinoxes, the center of this solar eclipse was located far south from Egypt. and therefore not visible in Egypt. But fortunately, its corresponding lunar eclipse that happened about 14.765 days earlier, or on May 8, 1385 BC at 21 UTC, was visible in Egypt using the same coordinates which I used for Djer's Sothic rise observation. You can verify this using Stellarium and by setting the algorithm of delta T to JTL horizons. The sighting of this lunar eclipse between 14 to 15 days earlier from the star rise of Sopdet on May 23, 1385 BC was enough sign for the Egyptians to know that a solar eclipse happened on the same day as Sopdet's heliacal rise, although this solar eclipse was not visible in Egypt. If we divide 523,046 days, the number of days between the start of two successive Sothic cycles, by 365 days, we get about 1,433.0027397 Egyptian calendar cycles. Multiplying this number of cycles by 0.256363,004 of a day, or the difference between a solar year and an Egyptian year of 365 days, we get about 367.3688871 days, which the date of the star rise of Sopdet has slided backward starting from the time of Djer. Subtracting 365 days from 367.3688871 days, we get 2.3688871 days, or 3 days, which the date of the star rise of Sopdet has slided backward from the 365th day of the Egyptian calendar. And this date is the 362nd day, which is also the second day of the 13th Egyptian month known as the 5 epagomenal days. During these 5 days, the birthdays of 5 Egyptian deities are celebrated one day after the other in the following order: Osiris, Horus the Elder, Set, Menophres, and Isis. If the second day of the 13th month is to be the end of a previous Sothic cycle, as well as the start of a new Sothic cycle, then the birthday of Isis, coinciding with the star rise of Sopdet, has to be celebrated on the second day of the 13th month in 1385 BC, or the same day as the birthday of Horus the Elder. It will necessarily omit or cancel the birthday celebrations of Set and Menophres happening on the third and fourth day of the 13th month. Furthermore, the birthday of Horus the Elder coinciding with the birthday of Isis, which happens only at the end of a Sothic cycle, gave rise to the myth of Horus the Elder, or Heru-Ur, son of Nut, being reborn as Horus or Heru, son of Isis. This rebirth of Horus the Elder into Horus was also the rebirth of the sacred phoenix, or the Bennu of Heliopolis, which is a symbol of rebirth and was celebrated at the end of every Sothic cycle.